Before I show you the new atmospheric edition, I will talk about the new frame I drew. As you can see, most of the menu is still the same. The only thing which looks different is the page where you play the game. It is inspired by those furniture with wood carvings on them, but instead of wood carvings it should resemble wrought iron. Even though it is definitely an improvement, it is still obvious that it is done by a beginner in pixel art. Because of that, I will have to improve that if I want to have a polished look in the end. Currently, most of the buttons and status bars are just part of the image, but the buttons menu, tutorial and options work. Now I will reveal what the new feature is. It is a new weather system. For now I only have implemented clouds. They are already pretty versatile. Here are a few examples. Pygame builds everything graphical with surfaces. The screen is a surface, images are surfaces, my individual sprites are surfaces. For the clouds I added a new layer, the shadow layer. That one is transparent. No, that's actually wrong. It does something different. This shadow layer is using the conventional three colors of red, green and blue. And here comes this specific function into play. The way I normally split a surface onto another one makes that all the colors get replaced. On the screen you can see what I mean. To the left is the surface with a color gradient on it. Black has the lowest value with 0, 0, 0. White has the highest value with 255, 255, 255. The icon is filled with a 50% gray of the values 127, 127 and 127. If I use the split command above the rectangle to the right, you can see how it turns out. The icon gets placed onto the surface and replaces all the colors. But it is not necessarily the case that the split command replaces the pixels of the surface with the pixels of the icon. The split function can do other things as well. For example, this max function compares the pixels of the surface and the icon and takes the one with the higher value. Since the surface has a color gradient which is brighter in the right half of the icon doesn't get printed onto the surface layer. Obviously there is an option for the min value as well. Those two can be used for cutting out stuff. For example, if we have a surface which is completely black with the exception of a rectangle, then only the stuff within that white rectangle is visible on the surface. There is also the add and subtract function. As their name indicates, the add option adds the value of the pixels from two surfaces together. To the right, this bright part of the square has a color gradient as well. It just isn't as visible to our eyes since the big square around it has a color gradient as well. The subtract function does basically the same, it just makes everything darker. With the shadow surface I use the last option available, it's the multiply option. That multiplies 2 pixels of the two surfaces and divides it by 255. If we have one surface which is completely white, then the result will look exactly like the other one. To the right you can see the math for it. White means each of the 3 base colors have a value of 255. If we divide that by 255, then we have a result of 1. And 1 times any value equals that very same value. If we have a surface which is completely black, then the end result is a black surface. The reason for that is that black means all colors of a pixels have the value 0, and 0 times anything equals 0 again. If I have a completely red surface, then only the red colors of this other surface will get splitted onto the screen. The idea is the same as before. The red part of the pixel is 255. And if we divide 255 by 255, we get 1 again, which means all red aspects of the resulting surface is the same as the other one. But when it comes to blue and green, we have a 0, which means that their content doesn't get splitted to the resulting surface. So in other words, with this shadow surface, I can make the game surface darker wherever I want and however I want. but I can't make it brighter. In this case, that isn't much of a problem as I'm working on a shadow surface after all. I have a dislike towards Perlin Noise. It is a very good mathematical function, but it is overused in games. Some games use it as a landscape generator and they just look off. The landmarks are repeated and there are no cliffs or overhangs. Of course there can be done quite some improvements to it, but the basic problems are still there. For my clouds, the problems don't apply though, especially since I will make the clouds large enough that the pattern is not visible. In Perlin Noise there are several parameters you can change. To me the only interesting one are the size in X and Y direction and the level of detail. In screen I showed 3 variations I can make while changing those. So far I haven't tried what it looks like when I change them during runtime. Perhaps I will do that at some point. I think they will start jumping around and can't be used because of that. But I don't really need that to work as I can just change the cloud patterns if I move between different maps. Let's go to the code. There is a noise library for Python which can draw 2D Perlin noise. I call that noise library for each individual pixel. The output value is a number between around minus 0.53 and plus 0.53. I have no clue why it is not a round number, but it doesn't really matter. The surface has a color range of 0 to 255. That means I have to turn minus 0.53 to 0 and plus 0.53 to 255. Here's the math for that. And then we have the Perlin noise scale to the range which can be used for the colors. I don't know if I will use it, but I thought it would be nice if the contrast of the clouds can be increased or reduced. If I use a contrast value larger than 1, it increases the contrast of the clouds, and if I use a value between 0 and 1, then it reduces the contrast. While editing, I also added a brightness value. When I just reduced the contrast, then it was a bit dark and grey, and this is not always suiting for the mood. So I can just add or subtract a constant value here, but I'm too lazy to change the graphics of this video now. The range which the colors can work with is from 0 to 255. This means I have to cut out the things which fall outside of that range. I do that with a simple if statement. With that I can draw a grey Perlin map. But that is a bit boring. Shadows of clouds are normally not black. They have a bit of bluish tint to them. At first I tried to make my own coloring of the shadow layer, but the end result was unintuitive to use and had quite a few limits to it. Because of that I ditched that code and searched how the professionals do it. Photoshop is an obvious first place to look for color gradient. Photoshop can do a whole lot more than I need. I just want to be able to place color markers at any place of the grayscale and the code calculates a gradient between those two markers. On a few forums I found out what type of calculation they use for that, but it was incomplete, so I had to figure out the rest of the calculation. If you need to visualize math, then I can recommend Wolfram Alpha. That is a great tool I used at my university days. This is the end result. I won't explain you the entire calculation, but I will give you a short overview. At the top are just the definitions of the symbols I used in the calculation. The calculation for the position, or pos, how I labeled it here, is done in a separate calculation to simplify it. To the left I calculate the values of the color at the current position. To the right is mostly about the shape of the gradient. The value st is about the steepness of the curve. If I make st a small number, the blue line here would be a straight line, and if I make it a higher number, it starts to bulge out. I wrote down the calculation 3 times as it is done 3 times for each pixel. Once for red, once for green and once for blue. So far I told you how to make it a static image, but there is one little problem. I'm using Pygame and that is not the fastest programming language. When I draw the shadow surface, I draw it pixel for pixel, which means I call the Perlin noise function 1 time for each pixel and I calculate the color gradient 3 times for each pixel. That slows the game pretty quickly. Perhaps there is a library which can calculate the Perlin noise more efficiently, but I didn't search for that. I went with the approach of reducing the amount of pixel needed to be drawn. Obviously, the game in itself already has an impact on the frame rate. Because of that, I start showing the frame rate of the menu where barely any code is executed. As you can see, the frame rate is not 100% stable. The menu has about an average of around 120 FPS. When I switch to the game but have the shadow surface disabled, then the frame rate is slightly lower. Of course, there will be more delay added when the mobs are added to the game, but an average of around 100 FPS is still pretty good. Now we add the shadow layer to the game. My very first implementation is to just recalculate everything each frame. I represent the updated pixels with a red color. As my game screen is 400 by 400, this means I have to call the Perlin function 160,000 times per frame. It is obviously that this has an impact on the frame rate. And as you can see, the frame rate drops to around 19 FPS. That's also why I started thinking about optimization. My first thought was dividing the shadow layer into chunks, like I did with the tiled maps previously. The smaller the chunks, the less pixels have to be drawn. If I move fast or if there is a fast wind speed, several rows of chunks have to be drawn at the same time. Let's just go with a chunk size of 10 pixels. That means it is 4000 times which the Perlin library has to be called. This is already 40 times better than previously where I recalculated everything every time. With an average frame rate of around 45 FPS, this is already in a usable range. While I was fighting with a few implementation problems, I thought, why not just draw the number of pixels which the shadow surface moved? In hindsight, this is such an obvious thought. So I immediately switched to that approach. This basically means the quicker the cloud moves in relation to the camera, the laggier it gets. But I can't do anything about that. As an example, let's look at a wind speed of 3. 3 times 400 pixels means I have to perform the calculation 1200 times. That's still a lot and still has an impact on the frame rate, but it is way better now. We are now looking at a frame rate of about 70 FPS. While I was at it, I thought of plotting the FPS in relation to the average wind speed to get a view on how it looks. I did the test 2 times, once where the wind was moving north and once where the wind was moving northwest. If it is moving just in one direction, then only one direction has to be updated. If it moves diagonally, then 2 sides have to be updated. I picked the angle of 0 and 45 degrees as they are the 2 most extreme cases. With that I mean an angle of 0 degree leads to the lowest frame rate impact and an angle of 45 degrees leads to the highest frame rate impact. Here are the numbers I got. Each data point is the average FPS of the game running for half a minute or so. What I don't know yet is if running it from an exe file makes it run faster. And I also don't know how other computers deal with it. I also haven't implemented things like mobs, projectiles and so on to the game, but that's a thing I will just ignore for now. According to this diagram, if I don't want to drop below 30 FPS, then I shouldn't have wind speeds above 10. If I don't want to drop below 50 FPS, I shouldn't have wind speeds above 6. I first wanted to show the wind speeds I just mentioned. But while recording with OBS it added additional lag, so I will show wind speeds of 1, 3 and 6. First in north direction and then northwest direction. When you look at the wind speed 6 you can see a bug I noticed while creating this video. I had quite a few of that sort. The bug is not a problem as I will find a solution for that. But if I want to make the game run smoothly, I should try to prevent a slowing of the frame rate. Low wind speed should be enough for most cases. But when I add a fast sprint to the game, the shadow surface will move quickly in relation to the camera. There would be the optimization left to just reduce the pixel count of the clouds. If the clouds are large enough, then that isn't a problem as the color change is not really that pronounced. Perhaps you haven't noticed, but so far I have talked about all those cloud movements in pixel units. With the player walking, that isn't a problem, as the player walks with a multiple of 1 pixel size. But if we want to have a slow wind speed, that is not true. Because of that I have added a sub-pixel movement for the wind. The wind has a speed and a direction. A speed of 1 means the wind moves with 30 pixels per millisecond. A direction of 0 means the wind goes north, 4 is west, 8 is south, and 12 is east. Just like speed, a direction is not bound to integer numbers. I can have any number between 0 and 16. I use cosine and sine to calculate the wind speed in both axes, and that obviously creates numbers which are not integer. Let's take a speed of 6 and the direction of 1. The movement into x direction is around 2.2 and the movement into the y direction is around 5.5. The resulting number I split up into two parts. The part in front of the decimal point gets written to the current cloud position, and the parts after the decimal point gets stored temporarily, and it will be added to the next time the number is calculated again. With that, even if the wind speed is slower than a pixel per frame, it still accurately calculates and displays the cloud position. I think it is apparent that it took me a while until I got all of this right. This had a lot of math in it and I implemented it by trial and error, which obviously led to every mistake one could make. I had sign flaws, I mistakenly checked for greater instead of lesser than, I drew the pixels to the wrong place and many other things. But now it is working fine. And after I have done everything, I had to recreate the math again and display everything I did in a nice looking slide for you to view. But now I'm finally done. It took me long enough to make. My next step might be to create shadows for the objects themselves, or transitions between different weather types, or whatever else I can think of. There is still loads to do. Goodbye, see you next time, whenever that is.